Today's lesson is on how do we perform operations with scientific notation. Problem 1. The mass of the moon is 7.35 times 10 to the 22nd, and the mass of the earth is 5.97 times 10 to the 24th. How much greater is the mass of the earth than that of the moon? Take a second to copy down the question. Now, if I want to determine how much greater is the mass of the earth than that of the moon, I'm going to have to take the mass of the earth, which is 5.97 times 10 to the 24th, and subtract the mass of the moon, which is 7.35 times 10 to the 22nd power. Now, when you're adding or subtracting numbers in scientific notation, we need the exponent with our power of 10 to be the same. So I have a 24 and a 22. Now these two exponents are not the same, so I have to convert them so that they are going to be the same. I can pick either one that I want to change. I'm going to change this first one because that's the first number that I see. If I want to change this 24 into a 2, I have to move my decimal 2 places to the right. So I get 597 times 10 to the 22nd minus 7.35 times 10 to the 22nd. Now, since my number 10, the exponent with my 10 is the same, I'm going to have that as part of my answer, and I can just subtract 597 minus 7.35, and that gives me 589.65. Now I have to check to make sure that my final answer is in scientific notation. This number is not in scientific notation because 589.65 is not between 1 and 10. So I have to move my decimal 2 places to the left. And I get 5.8965 times 10. And since I moved my decimal 2 places to the left, my exponent has to increase by 2. So it's going to turn into a 24. So this is my number expressed in scientific notation. Problem 2. There are 1 times 10 to the 14th good bacteria in the human body. There are 22.6 times 10 to the 18th good bacteria among the spectators in a soccer stadium. About how many spectators are in the stadium? Express the answer in scientific notation. Take a second to copy down the question. Now, since I need to determine how many people are in the stadium, I can take the number of good bacteria that is in the stadium, which is 2.6 times 10 to the 18th, and divide it by the number of good bacteria in the human body, which is 1 times 10 to the 14th. Now, when I am dividing numbers that are in scientific notation, I can look at each part separately. So the first part is the 2.6 over 1. I can just divide those numbers. 2.6 divided by 1 is 2.6. Then I can look at the 10 to the 18th over the 10 to the 14th. I can use my exponent rules to divide these and subtract my exponents. 18 minus 14, and 18 minus 14 is 4. So it's 10 to the 4th power. Then I can take my numbers and combine them. So I have 2.6 times 10 to the 4th power. And then I check to make sure that my number is in scientific notation. And since 2.6 is between 1 and 10, my number is in scientific notation. So this would be my final answer. Problem 3. A scientist estimates that there are 5.4 times 10 to the 4th bacteria growing in 3 times 10 to the 3rd petri dishes. About how many bacteria are growing in total? take a second to copy down the question. If I need to determine how many bacteria are growing in total, I can take the number of bacteria, which is 5.4 times 10 to the fourth, and multiply it by the number of petri dishes, which is 3 times 10 to the third power. Now, when I am multiplying numbers that are in scientific notation, it is very similar to dividing. I do not need my exponents to be the same. I can just take 5.4 and multiply it by 3. 5.4 times 3 is equal to 16.2. Then I can multiply my tens with the exponents. So 10 to the fourth times 10 to the third. Again, I can use my exponent rules, and since I'm multiplying, I'm going to add my exponents. So 4 plus 3 is 7. So I get 10 to the 7th power. Now, I would just combine my two numbers, 16.2 times 10 to the 7th power. Now, I see that 16.2 is not between 1 and 10, so this number is not in scientific notation. I have to move my decimal one place to the left and get 1.62 times 10. Now, since I moved my decimal one place to the left, I have to increase my exponent by 1. The 7 becomes an 8. So I get 1.62 times 10 to the 8th power. Now here's a review. When we're adding and subtracting in scientific notation, I need to change one of the numbers so the exponents are the same. If the exponents are not the same, I cannot add or subtract. If I need to make the exponent larger, I'm going to move my decimal to the left. If I need to make my exponent smaller, I can move my decimal to the right. Once I have the same exponent, I would add or subtract the numbers and keep the exponent. Then, convert my number to scientific notation if it's not already in scientific notation. When I am multiplying in scientific notation, I would first just multiply my numbers. Then I would multiply my tens with the exponents by adding my exponents, and convert my number to scientific notation if it's not already in scientific notation. When I am dividing in scientific notation, I would divide my numbers. Then I would divide my tens with the exponents by subtracting my exponents. And finally, convert it to scientific notation if it's not already in scientific notation. Now, complete these 3 problems and upload them to the Flipgrid.